So today's video is going to very quickly go over what we call the zero product property, and it's something that we use to help us solve polynomial equations. It's very intuitive, so let's look at our first example. So this pretty easy example actually identifies the entire property, so let's start working with this. Let's say Greg and Monica both have secret numbers. So Greg here is thinking of a number, and then Monica is also thinking of a number. Now we don't know what numbers they have. But what we do know is if we were to multiply their numbers together, we'll get 0. So we will never know exactly until we look what numbers they have. But there are some things that we could conclude. If I multiply two numbers to be 0, what we would then know is either Greg or Monica has 0 as a number. So for example, let's pretend that Greg had 0 and Monica had any other number like 5. Well, 0 times 5 would give us 0. So that's an example I can write down here too. Like 0 times 5 would be 0. Well, maybe Monica had 0. So no matter what number Greg had, maybe it was 10, maybe it was 15, maybe it was 64. If Monica has a 0, no matter what Greg has, then their product's going to be 0. But it also works out, what if they both had 0? So what we're realizing is if these two numbers are going to multiply together to be 0, either this number is 0, this number is 0, or we could say, or they both have 0. That's our general intuition. So let's actually do it with a real problem. So again, Greg and Monica are both thinking of secret numbers. Now, the only thing that they tell us to help us with their secret numbers is that when we multiply them, we have to get 0. So the only thing that we can conclude to be true is either one of these situations. Greg has 0. Or Monica's number is 0. Or they both have 0. So in this case, let's actually check. Let's see which one of these is going to be true. So let's go ahead and see what Greg's number was. Greg had 0. So this was true. Greg's number was 0, and when he multiplies it by Monica's number, which happened to be 3.14159, their product is 0. So what we're able to conclude here is one of these people has to have 0. Now, when we conclude that one person has to have 0, we might not know what the other person has. And it doesn't matter. As soon as I find out when Greg has a 0, it doesn't matter what Monica's number is. Greg has a 0, and that's a fact. Monica's number could be anything else. We might not know that second number, but we're trying to conclude is one of these people has 0. So get another example. So again, Greg and Monica are both thinking of a secret number again. And what they tell us, if we were to take both of their numbers and multiply them, we will get a 0. So what that means is either this number here, either Greg's number must have been 0, or if Greg's number wasn't 0, then the only way to multiply to get 0 was to have Monica's number equal 0. So one of these must be true, or they both could be 0. That would make sense. So let's go see who it was. Did Greg have 0? Sorry. And Greg had the number 17. So it's showing you the number 17 there is what Greg had. And what did Monica have? Well, she had 0. So one of these was true. Yes, it happened to be this one. Monica had a 0. There was no way we'd ever guess that Greg had a 17, but that wasn't our conclusion. Our conclusion was that one of those numbers had to be 0. Let's do another one. Greg and Monica are both thinking again of secret numbers, and what we realize here is that if we multiply their numbers together, we are going to get 0. So what we must know then is either Greg's number was 0, because 0 times anything would give us 0. Or Monica's number must have been 0 then. If Greg didn't have 0, Monica must have had 0. So these are the two things that we know have to be true. One of these must be the case. Now, we'll never know what the other person has, but we know that one of these people has to have a 0. So let's check. So in this case, we will be able to see their numbers. So if we go look at whatever Greg had, so Greg had the number 0. So that was true. When I multiplied this thing was true. Now, it doesn't really matter what Monica has, but since we have the ability to look, Monica had 0 too. So in this case, What can we conclude? Well, one of them had to be 0, and in this case, we were able to show that both of them had 0. Let's extend it to 3 people all of a sudden. So what if there was 3 people all thinking of secret numbers? And what they're telling us again is we might not know what their actual number is, but what they're telling us, which I'm going to write down here, is if we multiplied them together, this number, so the first number, which was Greg's number, times the second number, which was Monica's number, times the third number, which was Jesse's number, that equals 0. What could we conclude? Well, if we multiply 3 things to be 0, one of these must be 0. Because if I'm going to multiply 3 things in a row, one of them has to be 0 in order for me to get a 0. So we'd go look. So Greg didn't have it. Greg had a 1. Now we can go look at Monica. And now we can see these other guesses. So Monica had the 0. So our conclusion was true. If we took 3 numbers and multiplied them together to get 0, one of the original numbers had to have been 0. And in this case, it was this one. One more example here. Greg, Monica, and Jesse are all thinking of their own secret numbers. And what they tell us is when we multiply them together, we're going to get 0. Now, in this case, we're able to look to see what numbers everybody has. So one of them has to have a 0. That's what we must conclude down here. One person must have a 0. Because 0 times anything is going to be 0. So let's see if Greg had it. Now I'm just going to start deleting these. So Greg's number was 0, so that works out. Let's go look at Monica's number. Monica's number, oops. She also had 0. Look at Jesse's number. And Jesse had a 1. Sorry, that's kind of weird right now. But Jesse had a 1, and we do see that if we multiply these 3 numbers, we still get to 0. So was it true that one person must have 0? Yes, in this case, actually 2 of them did. But that is our 0 product property. Now here is our formal definition. What we're saying here is if we have some sort of multiplication, so if 2 or more things are being multiplied together, so we're going to put it in symbols down here. So let's say we have A, so A is a number, and we're multiplying it by B, and then we're multiplying it by C. If we have a bunch of things being multiplied in a row, and their product is 0, then what we can say is one of those numbers, or maybe more of them, could be 0. So if I multiply these 3 numbers to be 0, A could be 0, or this number could be 0, or this number could be 0. Just like another quick example, if I was going to multiply x plus 1 times this number x minus 3, and I got their product was 0. What I'm saying here is I have this first thing, x plus 1, is being multiplied by something else called x minus 3, and their product is 0. So we've met our requirements. We have 2 or more things being multiplied. Their product is 0. So then what we know is 1 or more of those numbers has to be 0. So this first number, x plus 1, could be 0. Or maybe this other number, x minus 3, was equal to 0. One of these must be true. And that's how we use the 0 product property. So let's use the 0 product property to solve these equations. So let's do something like we had 2x minus 1 was being multiplied by x, and we got the answer of 0. So if we were multiplying 2 things together, let's think about this as Greg's number, and then think of this as Monica's number. If they multiplied together to be 0, either this number, 2x minus 1, was equal to 0, or this other number, x, that must have been 0, because we have 2 cases. If it was 0 times x, that would still satisfy our equation to get 0, or maybe the other thing was 0, so if we had something like 2x minus 1, and then the x was 0, that again would still give us our answer. So we set up our basic fact, so then what would x be? Well, if 2x minus 1 was equal to 0, that means 2x was equal to 1, so x was equal to 1/2. But again, that's not the only way that we could get 0. If I plug that in, I will see that I get 0. So 2 times 1/2 minus 1, and then times x again, which is 1/2. I should get 0. So this is 1 minus 1. And then this is 1/2. So 0 times 1/2 is definitely 0. So I know this number would satisfy my equation. But that's not the only way that I could get 0. Nobody said that Greg's number was 0. Maybe Monica's number was 0. And we have to come up with all the possibilities. So if x was equal to 0, that's already solved for us. So x was 0. And if I plug that in, it does actually work out as a solution. So -1 times 0 is 0. So these are the two possible solutions to this equation. Our last example for today, we're supposed to solve this equation. And what I want you to notice is with this equation is we have three things that are grouped together. So this is our first thing, number 1. And then there's this next thing, which is 2x minus 6. That's number 2. And then we have a third thing in a row, and this is 4x. So what we're seeing here is we have three things being multiplied together, and their product is 0. This tells us to use the 0 product property. And again, what that means is that if I have three numbers all multiplying together to be 0, one of them had to have been 0. So maybe the first number, 3x plus 1, maybe that number was 0. Or maybe it was the middle number. Maybe 2x minus 6 was 0. Or maybe 4x was what gave us the 0. We don't know which one it's going to be. So we have to account for all of them. So if this number was 0, if this actually came out to be 0, x would have had to have been the number -1/3. So that's one possibility that I could plug in to get 0. Or nobody says it had to have been the first one. I don't know which one is the 0, but it could have been the second one, in which case the x value, if I add 6 to both sides and then divide by 2, maybe the x value was 3. If I plugged in 3, then the middle term would have been 0. Over here, if 4x, if the third number was equal to 0, that would give us the x value is 0. So any one of these is solutions. If I plug them in, like let's say I plug in 3 as an example. If I plug in 3, all the x's are equal to 3. Only one of these is going to be true at a time. So when I simplify, this is 10 times 0 times 12. And anything times 0 is going to be 0. So if I plugged that in, it would work. It could have been this number. Maybe the x value was 0, but the main idea here is if you plug in one x, you have to plug it in for all. So if I plugged it in here, 3 times 0 plus 1, and then 2 times 0 plus 6, and then 4 times 0. So this would have been 1 times 6 times 0, which is also 0. So again, any one of these would make the equation true.